Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Good afternoon, everybody, and welcome to the third and final of the three sessions on the green stage today, brought to you by Marine Energy Wales. Marine Energy Wales is the industry body representing the tidal stream, tidal range, wave and floating offshore wind industries here in Wales. For a final session, we're going to be looking at the technological innovation in the marine renewable supply chain, looking at some of the broader work being done to support the growth of this industry in Wales. So joining us today, we have Paul Ellsmore from MEIS, that's the Marine Energy Engineering Centre of Excellence, part of the Offshore Renewable Energy Catapult, and is here to help provide innovation support to the sector in Wales. We also have Saul Young of Meta, the Marine Energy Test Area in the Milford Haven Waterway, set up to help provide a de-risked stepping stone to marine energy deployments. Tim Warren of Blackfish Engineering, an engineering firm out of Bristol with specialist expertise in the field of marine renewables, who have gone on to work on a large number of projects across the marine industry. Charlotte Wood of Mainstay Marine, the boat builders who have gone on to become Wales' leading marine energy device fabricators, and David Glasby of Swansea University, whose academic research is being carried out to produce useful tools to help reduce costs in industry. So thank you to all of you who are joining us today to watch this session. Throughout the session, please feel free to submit any questions for our panelists as they come to you, and we'll try and address all of these at the end after each of them has presented. So without further ado, I'll hand you over to our first speaker, which is Paul Ellsmore of MEIS.
Good afternoon, everyone. I'm Paul Ellsmore from the Offshore Renewable Energy Catapult. And my colleagues actually gave a much more comprehensive presentation to Wales Tech Week on Tuesday. So this will be a bit of a summary of that. So I'll be able to rattle through my 10 slides. ORE Catapult is the UK's leading innovation centre for offshore renewables. Offshore renewables meaning wave, tidal, wind, tidal range. But about 80% of the work we do is related to offshore wind, which is now a huge market. Wave and tidal will have their time, but at an earlier stage of development at the moment. So just so you know, there are 9 catapults now. We're publicly funded by Innovate UK, and we're not-for-profit organisations, but all of the catapults do research and development in our chosen sector. Generally, we look a little bit like a university, but we sit much closer to the market than universities generally do. And our entire existence is in order to support UK industry. So whatever R&D we do is to help make our industries stronger. Today, offshore renewable energy is really all about fixed wind, and fixed wind off the east coast. As a result of that, some areas like Humberside, Teesside, Anglia have all benefited hugely economically. But the east coast, or the sea off the east coast, is nearly full now, and there's a focus on the Celtic Sea for floating wind, the Celtic Sea being the area, if you can see my mouse, the area around here. So a lot of Wales, Southern Ireland, and Southwest England. And right now, Pembrokeshire stands to benefit from becoming a hub for floating wind. And I guess Anglesey will reap benefits in the future from being a tidal stream hub. And in North Wales, there will still be fixed wind developments. So huge economic advantages there from offshore renewables. Offshore wind's probably the cheapest form of new electricity generation now, much cheaper than new nuclear and gas. And it's absolutely key to understand innovation has played a massive role in both cost and risk reduction. A lot of the new high-tech industries are finding a market in the offshore wind sector: remotely operated systems, autonomous systems, artificial intelligence, and we play a role in helping those outside sectors find a way into offshore wind. So we can support innovation at any scale and at any development level. We're involved in big projects such as GE's Stay Ashore programme and smaller projects like IMS's mooring load reduction system. And on the Stay Ashore project, that's a £9 million research project. And we're working with GE on that because we've partnered with them developing their Haliade-X huge new wind turbine. And the idea is that we want to eliminate, or at least drastically reduce, the need for people to travel out to sea to fix wind turbines. But we do support smaller projects. So for Intelligent Moorings Limited, we're supporting them. They're a North Wales company. Their technology allows for a reduction in peak loads that the mooring system of a floating platform, such as a floating wind turbine, would see. And if we can do that, then the mooring lines can be made cheaper and lighter, anchors can be smaller and cheaper. The whole mooring deployment system can be cheaper. And that's how innovation helps us continually drive down the cost of offshore renewables. So we're actually supporting IMS through MEES, our Marine Energy Engineering Centre of Excellence, which is based in Pembroke Dock. At the face of it, it's an £11 million project. It's part funded through WEFO, through ERDF funding, but partly through the Swansea Bay City deal. And that money allows us to collaborate with 4 Welsh universities, Swansea, Cardiff Met and Bangor. And we're very close to sealing that £4 million from City deal. We've been waiting for quite some time. So the point of MEES, we're here in Wales to support Welsh companies in the West Wales and the Valley region. That's the dark pink that you can see on the map on the right. We carry out R&D projects on behalf of companies. So we don't give out grants, but we can completely fund the innovation project ourselves. So we don't need to ask the company for a financial contribution. For instance, with the IMS, what we will be doing as MEES is funding the building of a prototype, so buying the components and putting those components together. Then we will fund attaching that to the mooring system of our own 4-metre diameter buoy, and we'll deploy that in META, the Marine Energy Test Area in the Milford Haven waterway. And we'll fund capturing all the data and feeding all that data back in a full report to IMS. And they won't be required to spend any money on that. So for MEES, our natural target clients are in the marine energy supply chain, and that includes fixed and floating wind, wave, tidal, and tidal range when that comes along. But we can support projects in any sector. Good examples being aquaculture and hydrogen, or actually any product or service that would benefit from being demonstrated in the Milford Haven waterway. We're pretty flexible on project timescales, anything from 6 weeks to 9 months for a project, and a wide range of budgets for that. But the other thing we do is we issue innovation challenges. So if you're not a SME with a clever idea you want to develop and demonstrate, you might be a company that has a problem, a technical problem that you need solving. So you could bring that to us. We'll put out an innovation challenge and see whether there's someone out there with a solution for your problem. And then we can fund and demonstrate that idea. So that was a very brief run through. That'll give us a bit of time at the end for questions, but here's how you can get hold of us. We have a separate website at mees.org.uk, and you can email us at mees@ore.catapult.org.uk. Or you can contact us directly at ORE Catapult through our info email address, or just go onto the website and see what kind of programs we're running that could be useful to you. So, thanks for listening.
Thank you for that, Paul. So yeah, if you are a supply chain company looking to access that support, feel free to reach out to Paul via those links. We'll drop some of those in the chat for you as well. So moving on from Paul, up next we have Saul, who is the operations manager at META, the Marine Energy Test Area, and he'll be talking a little bit about how this will assist the marine energy supply chain moving forward. Over to you, Saul.
Thanks, Jay. Good afternoon, everybody. I'm Saul Young, META operations manager. Just a quick one. META is the Marine Energy Test Area. It's Wales's national test centre, and we're based in Pembrokeshire. So to elaborate, Meta's mission is to reduce the time, cost, and risk faced by the marine energy industry in order to accelerate growth in this sector. We're looking to complement the existing test centre network present across the UK, including the Welsh demonstration zones mentioned by Paul. That'll be Morlice and the Pembrokeshire demonstration zone. Specifically, Meta sites can support testing programs for component and subsystem trials in less challenging conditions, up to trials of scale and full-scale wave and tidal energy generators in real sea conditions. As I mentioned, all the sites are in Pembrokeshire, in and around the Milford Haven waterway. This is a unique location with deep water port and extensive port infrastructure. There's also an excellent local supply chain, including engineers, fabricators, and marine contractors who have the skills and expertise to support projects from design and build stage through to installation and decommissioning. Ultimately, Meta is set up to support research and innovation and technology development. So to elaborate further, Meta supports technology developers get their kit in the water by removing the time, cost, and risk associated with consenting and site development. So we've taken all of that consenting and site development burden on ourselves and can provide a fully licensed site. So we provide a stepping stone between tank tests and full-scale demonstration. Ideal for supply chain. So supply chains develop companies developing new products and solutions, like the company Mesa working with IMS, can also come and test at Meta. These can be standard, general marine renewable energy supply chain companies, or other marine industries can also test at Meta. In addition, we hope the activity at Meta should stimulate demand for local supply chain, bringing in business and a chance to grow and diversify. Further, Meta can act as a hub for research and innovation and facilitate academic research. So we work closely with the Welsh universities on a number of projects so far, mainly monitoring and modelling work. However, there are lots of options for future collaboration between academia and industry, which Meta could facilitate, some of which are presented here. This could be around modelling, material testing, working with industry on full-scale devices or subsystems, as well as looking at developing new monitoring equipment or automated tools, and then validating these developments at Meta. So a little bit more about the sites. We have Meta Quayside sites. These are 5 highly accessible test areas, all associated with Pembroke Port. They're all fully consented to test components, subassemblies, and devices. They're sheltered and easily accessible, but still representative of a real sea environment to some extent. The testing activities here we'll be looking at and are consented are component testing, operational testing, dip testing of devices, support structures and moorings, testing, research and innovation, including monitoring work, deployment and retrieval methodologies, as well as including vessel approach and recovery, as well as health and safety procedures. So these sites are relatively low risk, where lessons can be learned quickly before higher risk deployments offshore. So then we have the Meta Phase 2 sites. These are more considered open water sites. These benefit from greater resource, whether that be wave or tidal resource, and greater depth. So we have the Delrose Wave Test Site, Warrior Way Tidal Test Site, and East Pickard Bay, which is for full-scale wave energy converters, but also floating wind component testing. Here we go. So as a newly operational test centre, we haven't, so we secured all our licenses and leases, at the beginning of this year. So we're a newly operational test centre. So some of the innovative technology tested at Meta so far includes drones for measuring surface currents. That's a Swansea University project. So a new method, which is relatively low risk and easily deployable for initial resource assessment and complementary to ADCP surveys. And we've also had a recent deployment at one of our quayside sites, Criterion Jetty, of a quarter-scale convergence beam ADCP, and David is going to talk a little bit more about that shortly. So some of the examples of innovative technology projects that are being considered at Meta include offshore hydrogen production, autonomous underwater vehicles, subsea batteries and charging stations, marine solar panels, novel communications and data logging systems, scour sensors, floating offshore wind components, mooring damper solutions, quick connect mooring and cable solutions, as well as what you'd expect in terms of generating devices. So this list highlights really that there's a lot more that goes into marine renewables than just the generating device itself. And there's a real opportunity for technology companies to diversify into marine renewable energy and apply existing knowledge and expertise. That's almost it. Just to finally highlight some of the investment going into marine energy at the moment, and that Meta is part of a bigger picture. So we're part of the Swansea Bay City Deal Pembroke Dock Marine project, and there's 4 pillars to that project, including the Port of Milford Haven, Wave Hub Development Services, and Offshore Renewable Energy Catapult MEAS project that Paul highlighted. And this project will deliver the facilities and services to set up a world-class centre for marine engineering in Pembrokeshire. And it's a magnet project really to attract and anchor other projects to the region. So thank you for your time. I'll leave it there. So if you would like to ask any questions about Meta or any of the projects that I've introduced, or if Meta can facilitate any of your testing needs, please get in touch. Our details are there, and I'm sure we can share them in the chat. Thank you very much.
Yeah, thank you for that, Saul. Again, we'll drop some of those contact details in the chat. So if you're a company that is interested in what Saul's just presented on, we'll provide an avenue for you to be able to get in touch with him. So yeah, thank you for that overview of some of the testing that's available for those that are looking to feed into the marine renewables supply chain. Up next, we're going to move on to Tim Warren from Blackfish Engineering, who are an engineering firm from Bristol, as I mentioned earlier, who have been actively involved in the sector for a number of years now. I'm sure Tim can tell you a lot more about it than I can, so I'll hand you over to him.
Lovely. Thank you very much, Jay. Right. Is that presenting and looking okay? Coming up now.
I've got a loop of this. Then I'm not sure if the PowerPoint was up.
The PowerPoint. I've got the PowerPoint up.
There we go.
Is that working?
Yep.
Good.
Yep.
Right. Okay. So thank you very much for the introduction. And
it's just not in full screen. It's just still in the window. There we go. Perfect.
Yeah, so thank you very much for the introduction. Yes, hopefully tell you a little bit more about Blackfish, but more importantly, what we've been doing in terms of innovation in the marine renewable sector. So as Jay mentioned, we're mainly based in Bristol, but we also have offices in North Wales and in Scotland, so we're fairly well spread across the country. And fundamentally, Blackfish Engineering, for those that don't know, is an engineering consultancy. Fundamentally, we love finding innovative solutions to complex engineering problems, and our track record fundamentally is in the offshore renewable sector. So we've got a lot of experience there, mainly mechanical engineering design, structural engineering, and analysis. And we've been involved over quite a few years in a number of wave projects, tidal projects, and also wind projects. So we've been involved with device prototypes, as you can see on the screen there. And I'll come on to one of those in a moment, but also test rigs, subsystem design, and tooling solutions. Very briefly, the kinds of stuff we cover, all engineering activity from concept design of devices or subsystems through detailed design and manufacturing drawings, stress analysis and modeling, loads modeling, and then also pretty importantly for these kinds of devices is the validation and verification, and this across a number of renewables industries: wind, wave, tidal, hydrogen, etc., as I mentioned. But you don't really want to just know about Blackfish. I'm sure you're here to find out what projects we've been involved with and how we've been helping innovation in Wales and in the UK. So I've got 3 slides to show you. on 3 projects. The first one is Motion. So I'm not sure how many people will be aware of the Motion project. If you're not, I strongly advise you to get on the internet or LinkedIn and look at what they've been doing, because it's a brilliant project. So the guys are based up in Edinburgh and came up with a concept design, and Blackfish Engineering have basically been their mechanical engineering design team. So we've been very closely involved with this project for about 3 years now. Pretty much everything in yellow that you can see there is our mechanical engineering design. So we've been involved with all the structural design, loads, stress modeling, as well as the hinges and the seals and the bearings, and all the internal subsystem integration as well. So that's mounting of all the electrical cabinets inside, the lighting, the bilge systems, etc. So this project, the video that you can see there, was taken about a month ago up in Rosyth for the first wet commissioning test. So it's not generating there; it's just doing the first floating test. But that's now already a little bit out of date, because the machine's up in Orkney, and it's out at sea, and it's been generating some power. So this is a great success story for Wave Energy Scotland, and the projects that they're involved with, and hopefully we'll go on to bigger and bigger things with larger and larger wave machines from Motion, which is a great success story. The second project I want to talk to you about is also related to Wave Energy Scotland, actually. So this is Blackfish's own technology development rather than acting as a consultancy. And in partnership with Wave Energy Scotland, we have been involved with their Quick Connect system. The previous presentation that you saw mentioned Quick Connect devices, so we've also been in discussion with Meta about how we might be able to test this device in Pembroke Dock, which would be really exciting. But basically, we've come up with a solution for enabling wave and other floating energy devices, it might be tidal, as well, to be connected remotely to an electrical and a mooring connector. So the solution we've come up with, and is currently around the TRL3 level, so we're still talking about desk-based analysis, is a solution that massively reduces HSE risks. There's no ROVs, there's no divers, there's no deck operations, no personnel transfers, and the vessels don't get anywhere close to any of the hardware that's at sea, so it's pretty safe for the vessels as well. This also brings with it advantages in terms of the sea state that we can operate in, so that you can connect and disconnect a device in wave conditions up to 2 meters HS, and reasonable also 1 meter per second tidal flow speeds as well. And there's no reason that you couldn't do this in darkness. So it massively opens up the operational window, which improves availability. The connection itself is actually entirely passive. There's no actuators, stored energy systems, or complex mechanisms, and no control system as such either. It's a passive mechanical connection, so which improves reliability, and doesn't have a particular interface or integration issue with the device itself. Only a couple of pad eyes for the mooring connection, and an electrical cable. So we're not requiring the devices to fundamentally change their architecture either. We're currently waiting to see if we've got if we're successful in the stage 3 Wave Energy Scotland program there. News will hopefully come out next week that we've been successful. And this is, as you can see from the logos at the bottom of the screen there, it's a very collaborative program, this, with Wave Energy Scotland, and companies across the southwest, and Scotland, involving developers, Motion Energy as well, Nova Innovation, Flow Wave Test Facility in Edinburgh, and a test centre up in Fort William. And as I mentioned, we're also talking about a parallel program of development with Meta. So hopefully that's going to be a great story to follow, and we'll shout about it if and when we win. The final project I wanted to talk about was a project that we've completed now called Fodtech. So this project fundamentally was all about learnings, and spreading those lessons learned to the wider renewables industry of how structures perform when they've been subsea for long periods of time. And this was based around a tripod structure that the tidal generation turbine. I'm probably quite small on your screen. There's a photo over my shoulder of the turbine that used to be installed on the tripod. And the tripod had been installed in Orkney at the Fall of Orness for about 10 years or so. It was then cut free and inspected in a number of ways. So there were biofouling surveys completed. We measured up to 12 centimeters of biofouling on this tripod structure, which has some pretty significant impact for decommissioning operations in terms of mass, in terms of buoyancy, and how you lift these structures if they're now massively thicker than they were when they went in. The top left picture there is a demonstration of some subsea ROV technology, scanning technology, that was used and proven on this case to. And so instead of doing a video survey using an ROV, this is effectively taking a 3D scan and producing a point cloud data set that you can then look at in a CAD model. So instead of having to watch the video and get worried that you haven't quite got exactly the right video angle that you wanted, we've now got a complete 3D model of that tripod, and you can look at it from whatever angle you want. It's a really amazing tool and really helps the decommissioning planning to have that kind of data available. You can really see what it is that you're dealing with on the seabed. The other strand to this was also the performance of the components that had been on the seabed for 10 years, most notably the electrical and fiber optic connectors. You can see some photos of those on the bottom right. Actually performed pretty well over 10 years. Yes, there's some biofouling, not a lot of corrosion, but you'd expect that from the titanium and super duplex materials that were used. But again, really interesting results of how these things perform when they've been submerged for 10 years. The purpose of the project is to take these lessons learned and spread them to the wider marine renewables and offshore industries. I presented last week at the Structures in the Marine Environment Conference and also the Marine Energy Wales working group. So we're spreading the message, and certainly if this stuff piques your interest and you want to find out more, then just get in contact and Google Blackfish Engineering, and you'll find our phone number. Feel free to get in touch. There's loads of information about the biofouling and corrosion here, and our phone number and contact details are at the bottom left there on the slide. So yeah, that's all I was going to tell you about today. Some pretty exciting projects that we've been involved with for innovation, and hopefully there'll be more great news to follow when the results come through in future years. Thank you very much.
Thank you very much for that, Tim. There's a good overview there of the broad suite of activities that you've been involved in relation to marine renewables. So next, we're going to move on to Charlotte Wood from Mainstay Marine, who's going to talk about Mainstay's experience of being a boat fabricator transitioning into the marine renewables sphere. So over to you, Charlotte.
Okay, thank you. Is my presentation coming up? Yes, it is. Okay. Good afternoon, everybody. As Jay said, my name is Charlotte Wood, and I'm the Business Development and Marketing Manager at Mainstay Marine Solutions based in South West Wales. Firstly, thank you very much to Marine Energy Wales for inviting us to speak here today. We are proud to have become involved in this industry and are grateful for the opportunity to share our journey so far. I will start by telling you a bit of background into our company, telling you a bit about who we are and how we diversified into the sector, and where we see future growth. So essentially, we are marine engineers. We manufacture large, heavy and complex semi-submersible and submersible structures. This is our 4.6 hectare site on the Milford Haven Waterway next to the ferry terminal in Pembroke Dock. Our core management team have been designing, building and servicing commercial vessels here for over 35 years. And our expertise lies in building bespoke commercial vessels in steel and aluminium up to about 40 metres in length. We've exported vessels all over the world, and we have 65 core staff, including naval architects, electrical engineers, mechanical engineers, welders, fabricators and painters. And just to give you a few visuals here, these are some of the facilities that we have. we've access to deep water through 4 slipways, 2 of which are covered, and we have a 650-ton capability. We have a ro-ro slipway which can accommodate our 160-ton hoist, which we'll see in the top right-hand corner. And we have a wet basin for around 3 berths at a time. Workshop space, we have 4 new build halls in total, totaling about 400 metres squared of workshop space. And you can just see some of the boats that are being built here. A steel vessel at the top for the Isle of Wight, which is a floating bridge. On the bottom left, you will see a wind farm support vessel, I believe, being built at the time. I can't see what you're seeing right now. 2 seconds. Right, okay, I think I'm on track now. We have a wide range of vessels. We have a large vessel portfolio, inclusive of pilot boats, passenger vessels, survey vessels, patrol vessels. On the bottom right-hand side, the bottom right corner is one of 2 vessels we recently built for the Welsh Government Fisheries, a fisheries protection vessel. Crew transfer vessels, RIBs, ridge of inflatable boats, and multi-purpose vessels. We've also built a number of masts, the communication masts for the Type 26 frigate. So we have a marine engineering sector that deals with a number of different disciplines. This is a fantastic project for us that will that the frigates will go into the MOD's vessels. So essentially, we are a design, build, maintenance, and repair yard. So how did we diversify into the sector? Well, I would love to say that we researched the market and took extensive feasibility studies, but to be completely honest, we were opportunistic. We were first approached about the Tidal Energy Limited project back in 2014, and soon came to realise that we were ideally placed to build such a device. Not only did we have the relevant facilities and resources, but we quickly came to realise that the challenges we would face in building a marine renewable device we were already really dealing with on a daily basis when building vessels. Essentially, we would need to manufacture, assemble, move, and launch heavy lumps of metal. We would need to work with and protect materials which would need to withstand extreme marine extremities. And we'd need to overcome complex engineering challenges, notably around drivetrain propulsion. Essentially, becoming involved in the sector would fit our core competencies perfectly. So the first device we built was a 200 kilowatt, 200-ton device for Tidal Energy Limited. This was the first private project fully developed in Wales. And whilst this company is no longer running, it can be deemed a huge success as it did generate power. And this currently sits at the seabed in Ramsey Sound off the Pembrokeshire coast. And through a Tiger project, we look forward to seeing how this device is weathered, as it will soon be taken out and investigated before being refit and redeployed. The second device we built was the Ocean Wave Rower on behalf of the developer Wavetricity. In very simplistic terms, the device has large extendable arms, which is which you can see the orange component at the bottom. Either side of the vessel move up and down in the waves to generate electricity. The fourth device we built is a third-scale wave energy converter for company Amog Consulting. They're of Australian origin. But very simple in design, this device extracts energy from the notion of its pendulum structure. This device was built in the Haven and it was brought down to the Falmouth test site. We believe this worked really, really well, and the team are now upscaling the device at present through lots of design work. The largest device so far is that we are building the massive 850-ton wave device called the M-Wave for Bombora, and a number of different parts of the system as well, including the PTO, stab plate, etc. The sheer scale of this unit has brought a number of challenges, notably where we should park our cars, actually. It is all around our site at the moment. It's 75 metres long. It's a 1.5 megawatt device, and that will be going into the water by the end of this year off our ro-ro slipway. So please keep an eye on these developments. It's really, really exciting developments going ahead. Just last month, we secured our fifth project, which is a tidal renewable energy device with a crossbeam on top of it. We are doing some refit works to it currently. We've also built a new crossbeam across this tidal platform, which will be nearing sign-off imminently. And we look forward to working with the team on this device very shortly. I believe this device is going back to Yarmouth for testing, but I think the team would be able to answer a lot more questions than I would. So why do we think that we are winning these projects? I believe it's a combination of reasons. I believe it's our location in the fast becoming marine energy hub that is Pembroke Dock and its close proximity to test sites. It's our facilities, our waterside access and investment in the boat lift have really been instrumental for these kind of prototype deployments. And finally, our core competencies and marine know-how, which set us apart from the rest. So Mainstay will continue to strive itself as the Wales's leading marine energy fabricators. We see real value in being part of this industry, and it will play a major part in the future growth of the business. Not only can this industry contribute greatly to providing us a green, clean energy solutions for the future, but it will be a key enabler of quality employment for the future generations to come. Thank you very much. If you have any questions, please do drop me a line. Oops.
Thank you very much for that, Charlotte. If anybody who is watching is interested to find out more about the Bombora wave device, which Charlotte talked about, I believe you'll be able to access some of our earlier sessions to playback. We did have Bombora giving an overview of their device, and I can confirm that it is mahoosive, as Charlotte said, having seen it in person. But yeah, feel free to reach out to Charlotte again if you have any questions. Please, guys, as well, if you've got any questions for our panelists, drop them in the chat and we'll throw them out to the panelists at the end of the session. We're going to move on to our final speaker now. That is David Glasby from Swansea University, and he's going to talk a little bit about some of the tools that the university has been developing for the benefit of the industry.
Thanks, Jay. I'm hoping you can see my slides now. Is that right?
Yeah, all good.
Yeah, cheers. Yeah, hi, I'm David Glasby. I'm a research assistant, part of the marine energy research team here at Swansea University. Thank you for having me. I hope you find this presentation interesting. Presentation's entitled Technological Innovations in Current Measurement to Support the Tidal Stream Energy Sector. So just to touch on our involvement in the marine energy at Swansea University, on the left, we show 4 expertise areas within our team, that being field data and analysis, sensors and array models. Our 2 experimental facilities, the wave tank and the wind tunnel. And on the right, some of our main partners in with tidal stream, floating wind and lagoon technology. The 2 pieces of work in particular that we want to focus on in this talk, they're both innovative new ways of providing current measurement data that is ultimately going to help further our understanding of current speed and turbulence. And also drive down cost and complexity involved in this data gathering process. So why is current measurement data needed and why is it important? There are two reasons. Firstly, developers that want to put a turbine or some other device in the water at a tidal stream site, they want to know the best position for getting the most out of their device. We can do this by accurately mapping the currents over large areas, like you see in the bottom right images. Secondly, designing a turbine and a supporting structure for this environment needs a good understanding of the drag forces and in particular the fluctuating forces that come from turbulence in these fast flowing regions. If you get this wrong, you can end up like this wind turbine here at the bottom. So at Swansea University, through the Selkie project, are developing 2 new tools to support the marine energy sector, and the aim of both of these tools is to provide new understanding of tidal currents and lower the cost of acquiring this much needed data. So the first tool is a converging beam ADCP, or Acoustic Doppler current profiler, which is a device we can deploy to the seabed and it will record detailed turbulence measurements. The second tool is using drone imagery to map the speed and direction of currents, and this will provide a fast and easy way of getting this data, as well as giving a much higher resolution in comparison to existing methods. So looking in more detail at the Cadcp tool to begin with, this is a device that we've designed which has 3 single beam ADCPs mounted to a frame that is effectively a 10-meter equilateral triangle. The whole thing sits on the seabed for a month and takes current measurements of the water directly above it. So for those who aren't familiar, a conventional ADCP is essentially a flow sensor that works by transmitting and receiving an acoustic pulse along a number of beams that are angled outwards away from each other, as shown in the left-hand side. And using the Doppler effect, this allows you to measure flow speeds at multiple points along the length of each beam. You can then take an average at a given height above the seabed and do some maths, which will give you the current velocity. This method's good for finding an average velocity, but it's not so good for measuring turbulence above the seabed where the beams are far apart. So for this, what we are doing is using the same principles. We are converging the 3 beams at each other so that we're effectively moving the focal point where the beams collide up to a specific depth that we want to measure the turbulence at. And in doing this, we can calculate the XYZ components of the flow at that specific point, and this will give us a much better indication of how that turbulent flow is behaving. So progress so far, we've just last week completed a 1-month deployment at Meta's phase 1 test site on a quarter scale model. We tested out innovative low-cost way of deploying and retrieving from the seabed. So in the deployment, we dropped the Cadcp to the seabed on a line of rope from a raft that we made from scaffold and plastic barrels, which meant that we could use a much smaller and cheaper vessel for the operation. For retrieval then, we trialled an automated refloat system, which is why we have a barrel strapped to the device. So when we want to recover it from the seabed, we can add a whole load of buoyancy so it lifts itself to the surface. This again removes the need for an expensive vessel, and also there's no need for a dive team, which makes it far cheaper and fewer risks involved. This trial went well and gave us a lot of confidence going into the next stage of development, which is the full-scale build. We're at the final stages of the full-scale detailed design, which currently looks, as you can see in the bottom image. So future plans in the next 2 months, we'll be doing a full-scale fabrication and build. Then in September, we'll test the full-scale Cadcp at Meta's phase 2 site, which is Warrior Way, which will involve first trialing the deployment and retrieval methods again, followed by a month-long deployment with the ADCP sensors in place, which we hope then to have some data that we can validate against existing ADCP data from that area. Then finally, we'll be publishing the results, and we plan to make this tool open source for anyone that might find it useful. The second tool then is about looking at gathering current measurements over a much wider area. So currently the method for doing this involves mounting an ADCP to a vessel and floating back and forth in the area that you want to collect data. The problem with this is that, again, vessels are expensive to use, and the measurements you can get are only at various points along the path that your vessel takes. The top right image shows typically what that data set might look like. So what we are doing in this case is using video footage from a drone to create a 2D map of current measurement data. The benefits of this being that it's lower cost, low risk, better area coverage, and far more versatile in terms of where it can get to. This would be a good way of conducting an initial check if you wish to survey a particular area. It could be very beneficial for community level projects too. This method uses the PIV principle, or particle image velocimetry, which is well established in lab work. It essentially tracks particles between frames to calculate the velocity. And we're taking this approach and applying it on a larger scale to cover the tidal site. So activity today on this tool, my colleague Ian Fairley, who's leading this project, He's done a number of initial tests using GPS surface drifters and ADCP measurements to validate the drone data against. The top right graph shows that the results from the drone and the GPS tracks seem to agree with each other at higher velocities, which is the nice 1-to-1 slope. However, there's still some work to be done in refining the lower velocity readings, sort of below 0.7 meters per second. And we think this is effectively due to the waves and ripples on the surface that are causing the PIV to overestimate the velocity. And also, just to add, there is also work in the pipeline to looking at how the PIV readings and the currents at the surface relate to current at depth, which is partially why we had the ADCP measurements involved at this Ramsey Sound trial. So we have current readings at depth to be able to compare with what we're measuring at the surface. So to conclude, both these tools, the CADCP and the drone, are currently a work in progress. They show promise and hopefully will add a lot of value in terms of the tools that are available to developers, and they'll reduce costs, provide higher quality data of turbulent and wide area current measurements. They'll be open source tools, so that's the results, the methodology, the workflow guidelines, and the designs will be made freely available. We hope this will encourage developers to engage with academia and build working relationships of high quality so that we can help drive the marine energy sector forwards. That's all. Thanks. Thank you for listening. I'll hand back to Jay.
Thank you very much, David. So that concludes all the presentations now. So I'd like to bring up all of our panelists again, and we could perhaps go around with some questions and discussion. I'd be interested to know from some of our speakers what they see to be some of the challenges and opportunities from joining this sector. Perhaps either Paul or Saul might be in a good place to answer this, given that they work with and support companies that are entering the sector.
Yeah, okay. So we have to be blunt and honest. It's a difficult sector to be in, particularly if you're a device developer. If you're a supply chain company, there are opportunities, as Charlotte pointed out, to get involved in making these devices. They're pretty chunky, but they're done on a one-off basis. So it's attractive for a precision engineer and their supply chain to do a one-off, design it, build it, and see it in the water. As a device developer and a project developer, it's a tough market. It's as tough as offshore wind was 10 years ago, 15 years ago. It costs a huge amount of money, and without some subsidy on the power that you generate, there's no long-term source of income for you. But that, I think, is changing, and this could be a really good time for tidal energy in particular. Wave energy is probably a little bit behind, but if tidal can do a good job now, then that will set the stage for wave to come along afterwards. And I say it's a good time because there is a sense that Treasury and BEIS are now willing to actually put their hand in their pocket for a revenue support scheme that's similar to what offshore wind has seen. And when that happens, it's up to all of us to make sure that we do absolute best with that funding that we can to prove that the costs can come down. So effectively, I don't believe there's any technical challenge in tidal stream energy. There are still some technical challenges with wave, but for tidal, it's pre-commercial deployment now, and it's just a question of getting costs down to be competitive with the other renewable energy sources.
Saul, do you have anything to add on that?
No, I would totally agree with what Paul said, and yeah, there's obviously been a lot of learning already done, and these technologies are on the brink pretty much. We've got the orbital device, which is the most powerful tidal turbine in the world, being deployed, and they've got a commercial pipeline lined up. Bombora device, which is the biggest wave energy converter to be deployed in Pembrokeshire. So yeah, it's almost there. And yeah, like Paul said, it's the sort of that commercial incentive that will take it forwards now.
And Tim, as an engineering company that works broadly, beyond marine renewables as well as in marine renewables, is there any sort of like lessons learned from when you began working in this field, drawing on past expertise?
Yeah, so I think that the main one that just springs to mind, and I've used as I've recounted many times. So I've been involved in marine renewable since 2007, and I have to say, since then there have been many Jam Tomorrow promises about. In 2007 there were going to be, I can't remember, 100 megawatts of tidal turbines installed by 2012, and then in 2012 there were going to be another 100 installed by 2016, and it's been overpromised, and I think the offshore, certainly wave and tidal industry, has kind of not helped itself by overpromising. There are some huge technical challenges, and I think some of those challenges have been underestimated. There are some huge commercial challenges, and I think a lot of those have been seriously underestimated. But we're seeing now, with the success of the likes of Orbital and Nova, who've done, and the Maygem project up in Pentland Firth, we've seen some really great results, really good stuff, that turbines operating continuously for a really good number of years, and proving that tidal stream really works. But it's taken a long time to get here, and there's been quite a few false promises along the way. So I think probably the number one thing that springs out to me for this industry is not to overpromise and underdeliver. Yeah.
So there's a lot of mention of commercial challenges there from the three of you, and a lot of what Swansea University is doing is to try and address some of these commercial challenges and bring down costs. So how is sort of priorities identified within the research that Swansea University does, David, to help the industry?
I guess from the work that we've been doing on these two projects, it's aimed particularly at the large costs for vessels, for mobilizing a vessel that you'd need for deploying a device such as this one, just because of the size of the device and the deck space that you need for that. So we've put a lot of work into just low cost methodology for these kind of operations. I think that it'd fast track a lot of the data capture that we need that would help in the, I guess, develop for these designs.
And then of course your designs are open source as well. Have you so that all of the industry can effectively benefit from them? Have you had close conversations with developers in industry who are interested in your designs?
Not yet, we haven't. We're hoping that once we have something more promising, I guess, that it will open up and that we'll get lots of interest. Yeah, that'd be great.
Cool. I was hoping Charlotte would have been able to answer some questions on the sort of supply chain clustering that we're seeing in the Milford Haven area, but perhaps you can weigh in on that, Saul, being involved in the Meta project in the Milford Haven area. How are we seeing supply chain develop around this region in a way that is beneficial to people working in the area, being able to draw on all these companies?
Mm-hmm. Yeah, no, it's a good point. There is a lot of component parts that go into delivering these projects, sort of the design, the engineering design, and the build and fabrication work, and then deploying the vessel contractors. So yeah, there's a lot of, Mainstay have developed their capabilities, but there's also other engineering firms in the area. MEIS are working with multiple different supply chain companies to help develop their products and services. So yeah, there's a lot coming together, and hopefully, test sites like Meta, the Pembrokeshire demonstration zone, more like, stimulates that demand for supply chain. you know, like up in Orkney, for example, where they've had EMEC, is like loads of companies have diversified into marine renewables, and now it's a key part of their economy and, you know, jobs for local people. And, you know, then you've got the Pembroke Dock Marine project that myself and Paul touched on, which is part of the port infrastructure, but also these facilities and support services. So yeah, there's a lot coming together in terms of supply chain development.
It's good to hear. So yeah, drawing on what you said there about stimulating demand for local supply chain, perhaps we can go to Tim or Paul as the two people in the room who have been in the industry for the longest. What do you see as the kind of key areas that are helping drive that demand or stimulate the demand for local supply chains and clusters?
Well, I'll go first. Just have to say, first of all, it doesn't make sense to be too parochial about this. We need an industry. We need a market for people to sell into first and foremost. And it's great to see the likes of Mainstay picking up so much work. But it's absolutely key that the project developers and device developers get access to the best, and that's not necessarily always the cheapest, but the best support and facilities they can. As everyone always says, a small slice of a big pie is often better than a big slice of a small pie. So we're not particularly as ORE Catapult, a UK-wide organisation, we're not particularly concerned about trying to ring fence everything into Pembrokeshire. I can't even put my hand on my heart and favour Pembrokeshire over Wales. So I mean, I'm desperate to see North Wales succeed in supplying into the Morlice demonstration zone, for instance. But we're in a situation at the moment where even with offshore wind, where we are global leaders, we struggle to get UK content into it. So it's not a question of us doing the best we can for our local companies. We will do that, but we have to do the best we can for our industry, our market, which is you know, renewable energy in Welsh waters from our point of view, renewable energy from UK waters at a UK level. But I think it's also important to understand that it's a very much a top-down thing. Mainstay can do an awful lot of the work they do, but they could also subcontract that. They could also buy in components. But they're the people they are the company that people go to for their experience, having done some stuff. And that's what a cluster really is. So you don't have to have 90% of everything that's done in that cluster. What you have to have is trusted partners in that cluster and a breadth of trusted partners. So beyond the mechanical stuff, it's good to see we've had some solicitors move in who are keen to be big in the marine renewables sector. That, you know, all of that builds up. I'm hoping at some point in the future we'll start to get regulatory bodies opening offices in and around Pembrokeshire, and they'll do the same in Anglesey when that becomes really big business up there as well. And it's broadening everyone's experience. So there will be opportunities in hydrogen, and the handling of hydrogen and the handling of hydrogen vectors is very synergistic with the handling of oil and gas. And we've got massive experience in our area of manufacturing, of project management, all the rest of it in oil and gas that can be transferred across. But we have, I know Tim mentioned Jan tomorrow, we have all heard these stories about marine energy projects and how they're going to be the next best thing for the supply chain. It hasn't really worked yet, but I can tell you floating offshore wind is going to happen, and that's going to be big. And there are huge, huge add-on benefits for wave and tidal as an industry if floating wind can really establish itself in Pembrokeshire to service the whole of the Celtic Sea. That'll create enormous scale in the manufacturing base and the project management base that the tidal stream will just be able to plug into when it's ready, and which wave can come into later on. But my organisation is UK wide, so I can't in all conscience, be favouring Wales or even some small part of Wales over the rest of the United Kingdom.
Thank you for that, Paul. You've done a good job there of encapsulating what this means for the supply chain across a broader scale. Tim, do you have anything more to add in there? I'm conscious of time. We are going to have to wrap up soon.
I only had one thought really. Paul gave a very, very thorough answer. The only thing I would add in terms of you were talking about supply chain and trying to keep, and you shouldn't really keep the supply chain all particularly clustered. That doesn't necessarily provide the answer. A slightly different perspective actually is to do with developers, and actually we could do with all the developers succeeding. We don't want one developer to succeed at the expense of others. We need everyone to succeed, and that builds the industry much quicker, as Paul said, a bigger pie. And one aspect there I'll just touch on very briefly is sharing experience between developers. Having been in the developer world myself for quite a few years, people hold on to their secrets. They like protecting their IP. They don't really want to tell everybody else what they're doing, and I think that generally needs to change a bit more, and people need to share and work and collaborate a bit more to help everybody. Everyone needs to succeed to get this industry going.
I'll just add something to that as well. I mean, you're absolutely right, Tim. But Charlotte mentioned TEL and the Delta stream that went into the water, what is it now, 3 years ago, maybe longer than that. TEL actually didn't survive as a company. But the important thing is that everything it knew and the people who worked there have been recycled into the industry. So in my team at Meese, we have a person who was directly involved with TEL. In our Interreg project, Tiger, that Catapult runs out of Cornwall, but which is also has an interest in Ramsey Sound. We've got another person of that TEL team, Chris Williams, who was, I think, managing director of TEL. He went through a period with Bombora. He's now with DP Energy. Has stayed in not just in the sector but in the area, and I think that's what I was alluding to in terms of, you know, what a cluster is. It's not necessarily the fact that the nuts and bolts are being bought from within that cluster. It's the fact that the experience, the knowledge and the lessons are being captured in the companies that are local to that cluster. It's you know, it's more about experience and capability than it is about money, I think.
Thank you very much for that, Paul. Unfortunately, we are out of time now, so we are going to have to wrap up. Yeah, thank you to all of our panelists that have joined us today and everybody who's watching. If you want to find out a bit more about Marine Energy Wales and the work that we do, you can head to our website. That's www.marineenergywales.co.uk. You can find us on LinkedIn to keep up to date with our activity, as well as on Twitter @MarineCymru. And yeah, I'd also like to extend a thanks to the team behind Wales Tech Week, that's Technology Connected, for inviting us here today and for having us join them for 3 sessions. So thank you to everyone who's joining us. Have a lovely evening, and yeah, feel free to reach out to Marine Energy Wales or any of our speakers if you'd like to find out more about anything you've heard about today. Thank you and goodbye.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.